We're going to try and do the same thing that we did in the series video, except for given a parallel circuit. So here we have this parallel circuit. It's hooked up to a battery with some potential V, and then some current runs through, and it hits this junction point. And remember, in the previous videos, we said that there's current, total current, and then it has to split off into the different wires. So maybe we get what we call I1 over here. Maybe there's some I2 over here. And then I3 goes into this wire there. So altogether, this current has to split off into 3 different ways before it meets back up at the very end. So we could write an equation for this. We could say that the total current is equal to I1 plus I2 plus I3. But in parallel circuits, the thing we know to be the same, though it's not the current, is the voltage. The voltage across all resistors in this parallel section are the same. The voltage across all resistors is the same. So written algebraically, that looks like the voltage from this battery is, or also the voltage here, because remember, we're trying to take this circuit and turn it into a simpler one with just a battery and one resistor. It's V1 equals V2 equals V3. The equation that I'm going to work with, though, is over here. I'm going to pull this out here, and my argument is that this current, the total current, will be the same current running through my equivalent circuit. So I'll call this I equivalent. It's going to be the current flowing this way, I equivalent, which is the sum of all of the currents flowing through this parallel section. Well, if I use Ohm's law, which is I equals V over R, I can plug in some values here, and I get that the equivalent current is, actually let's plug it in even for that. It's the voltage over the equivalent resistance is the voltage over R1 plus the voltage over R2 plus the voltage over R3. I'm calling these all V because I know that all the voltages across each resistor in parallel circuits is the same. Notice I have a V in every term, so I could divide every term by V, causing each V to cancel out, leaving me with this expression, 1 over REQ. Equivalent resistance is 1 over R1 plus 1 over R2 plus 1 over R3 plus ... however many more I have hooked up in this parallel circuit. So in order to turn this into equivalent resistance, I could, let's say, let's put some numbers to this. Why don't we? We'll put this at a 9-volt battery. We'll put this at 6 ohms. We'll put this at 3 ohms, and we'll put this at 2 ohms. So if I want to figure out what this equivalent resistance would be, I could say 1 over R equivalent is, let me continue with the color coding, 1 over 6 plus 1 over 3 plus 1 over 2. Now you add up all of those terms, and then you would get